And here's one other way you can look at E. It's kind of a more elegant way if you appreciate that. E is actually equal to 1. Not quite. How about 1 over 1 to the factorial? Remember, factorial means 1 times every integer less than that number. Okay, so like 6 factorial equals 6 times 5 times 4 times 3 times 2 times 1. So 30, 120, 360, 720. So 6 factorial equals 720. All right, that's what factorial means. And it looks like an exclamation point. It seems like you should read it like, really excitedly, but that's not what it means. Okay, so E equals 1 plus 1 over 1 factorial plus 1 over 2 factorial plus 1 over 3 factorial dot dot dot. I think this is kind of interesting because these transcendental numbers tend to have simplicity built in to the heart of what they are and where they come from. Take pi, circumference divided by diameter. Simple, straightforward. E, in this case, all I'm asking is for you to say 1 plus 1 plus 1/2 plus 1/6 dot 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 dot, and keep going. Well, what have I got so far? 2 plus 1/2 plus 1/6. Which gives me 2 plus 1/2 plus 1/6 should be 2.66, I believe. So let me throw that number down. So 2.66 is where I ended up. But look, I only went out here in this sequence, in this series. I only went out to 1 over 3 factorial. How would I actually represent this as, I don't really want it to say 2.66, I want it to be E, like really E, 2.718289, I believe. Okay, that's not 2.66. I want it to be more accurate. Okay, so here's how you can actually accurately depict E in the form of a series, which is infinite. You have to do it something like this, and you could use sigma notation, but I'm not going to do that because I don't want to scare anybody. Okay. And then dot, dot, dot. Okay. And then where am I going? Where am I going with this? I'm going all the way out to where 1 over infinity factorial. Okay? So I think this red colored depiction of an infinite series of terms being summed together, okay, is an accurate representation of E, which you cannot write down in a decimal. You cannot accurately record E by writing numbers down on a piece of paper. You cannot say accurately 2.718281. You can't do that because you'll have to keep writing forever, and you'll never stop, and it'll never make a pattern, and it'll never be finished. It'll be irrational because That's the nature of irrational numbers. So the same thing would be true with pi. Same thing would be true with phi. Okay? Same thing would be true with the square root of 2. So this, however, this infinite sequence is an accurate way to record E. Kind of cool.